Okay, next topic is universal functions. These are the functions that are extremely useful. We'll be using these functions quite regularly, and fast element-wise array functions. So these are fast and element-wise. So you just say one command and it will go through, like find the square root. It will go and find the square root for all the numbers and so on. And table 4-3 has a list of the available functions. So let's create a random integers. Okay, so this time it's going to be integers. So 10 to 99, and we want 12 of them. So when you use rand integer, we have to reshape ourselves, unlike the normal distribution. Rand n, okay, you specify the shape, it will fill it out for that shape. Now here we have to reshape ourselves. Okay, so here are the numbers, and if you want to take a square root, okay, so this is what we were used to, right? So it gives you square root of all that. But the NP function is better. So if you do NP dot square root, so that will give you the square root of all of those numbers. So you want square, then you can do we have exponential. Okay. Now this table here 4-3 has a list of all possible unary universal functions. These are often called U-funcs, by the way. U-funcs or U-functions. These are universal functions. These are unary functions, meaning that you go and do this to each and every element in the array, right? Now you can, okay, we'll look at that later. So let's look at mathematical and statistical methods. So these are for the entire array or entire, in a given dimension. So you want sum, so you can say ARR sum, and that will give you the sum of the entire array. Okay. But if you want sum along a direction, then you have to specify the axis. If you don't specify an axis for sum, for these functions, basic array statistical methods, okay, the entire array is assumed, shall go through the entire array. Now if you specify axis equal to 0, so it will go by the rows like that, and then it will give you the sum. So it's going to give you 4 sums. So it will take row 1, row 2, row 3. So that sum, then that, and that. Okay. Now if you say axis equal to 1, then it will go, it will go through the columns for each row. So it will add all the columns up. Okay, one number, and then another one, another one. So that's axis equal to 1. And you can do mean if you like, ARR mean, ARR mean x is equal to 0. So I'm going to do this in one line here. So what will come back is a tuple. Okay. So first one is 77, and then we have these three, x is equal to 0. Okay, and then you have another one. What happened here? Okay, let's do it separately. So we'll have. Okay, so you need to, so if this happens, that means it's just setting up a function. You need the parenthesis. Okay, so you have 4 numbers, and then this will give you 3 numbers. X is equal to 1. Will give you 3 numbers. Okay. Now the standard deviation, you have to be careful, because standard deviation by default is population. That is, denominator is n. So if you do ARR STD, this will give you population standard deviation. So you want sample standard deviation where the denominator is n minus 1, then you have to specify that as DD of. Okay. You have to specify DD of as 1. Okay. Then that will give you with the denominator of n minus 1, and you see that it's slightly different. Okay. Yes. Population is n. Okay. Oh, okay. I need to move this down, I guess. Like that. Is that what you're asking me?
Yes.
Oh, okay. Yeah, it should come there. Okay. Now we already did this once before. You can have methods for Boolean arrays. So you can, if you create a Boolean array, and then you can apply these. Usually sum is a good function. So count positive numbers. Okay, so we have redone ARR. I should have kept the old ARR. Okay, so let's recreate the old ARR. So now we have some positive, some negative. And suppose we want to count the number of positive values, right? Then we can create a mask, ARR, and then you say ARR greater than 0. Okay. So that will create, well, that's going to get me the numbers, okay? So that's not, for counting, then you can say length, I guess. So that will tell us how many positive numbers are there. Okay? But we can convert this into a Boolean array, and then do, say, suppose if you, instead of that, if you make it ARR greater than 0, okay, and make that within a parenthesis, then that creates a Boolean mask. Okay, wherever it is greater than 0, you get a true, and wherever you have negative or 0, you get a false. Okay, and then you can do a sum of that. Okay, so suppose we want to capture this as a Boolean. Okay, okay, let's so this just creates on the fly Boolean mask. Suppose we do that, then ARRB is a Boolean array. Okay, the entire array has true and false, whether it is positive or not. Okay, and then we have a couple of methods that are very useful, and that is any and all. And this is useful for finding in a real life data whether there are any missing values. So you can create a Boolean array, where if it is missing, then true. If it is not missing, false. So then you will have an array where all the missing values are identified. Then you can figure out how many missing values there are and so on. And there are a couple of methods that are useful, is any and ARRB. Okay, and if you say any, okay, so which means are there any true values? Okay, of course there are. It's going to go through the entire an array and then tell you whether it is true or not. But suppose we want row wise, then you can say ARRB any, and you say axis is equal to 0, then it will go for each column, it will go row wise. Okay, it will take this column, see does it have any in the first dimension. So remember, axis 0 is for the first dimension. So it's going to look at the first dimension, and it will go through the all the values of the second dimension. So we can do this with axis equal to 1. Okay, so that is any. Are there any true values? Okay. And another one is ARRB all. Okay. Now, of course, this is are they all true? Okay. If you don't specify axis, then it's going to look at all the elements of the array. Then if you specify the axis, so it will look at the axis. Okay, so look at the first. So it goes, this axis is column, so it'll take the first row and it'll go through the columns, and all of them are true. So you get true here for all.